We're going to try something different for these consecutive integer problems. Okay, there are 3 of them in the review part of the packet. We're going to try to do them all in one video. First off, the let for consecutive integers was pretty much the last thing we did before we had this coronavirus break. So, just a reminder, consecutive odd and consecutive integers both have the same let. It's going to be x plus 2, x plus 4, x plus 6, x plus 8. And again, ignore the stuff in the red. That's where the problem is done already. So, that's our let for consecutive even or odd integers. All right, and then if we go to the next page, all right, regular consecutive integers gets the x plus 1, x plus 2, x plus 3, x plus 4. All right, again, number 6, back to consecutive even, and it says consecutive negative even. We said on those problems you ignore the negative or positive until the end of the question. But we'll get to that in a minute. Now, back to the first problem. Okay, this is the most basic of the consecutive integer problem. It says find the sum. Sorry, it says the sum of 5 consecutive odd integers is 535. Find the 5 consecutive odd integers. With this one, it said the sum of the 5 consecutive odd integers. So we just added up all 5. Add up all 5. X plus 2 plus x plus 4 plus x plus 6 plus x plus 8 equals 535. Very basic. Just combine your like terms. There's not even any distributing to do. We get our 103 as our answer. Okay, after we combine like terms and solve the two-step equation, we go back to the let, plug it in. Okay, we have a sentence again. Okay, and our check is to add all 5 up. Hey, Tim.
What is it?
Can you be quiet while I do this video, please? Please?
Okay.
Thanks, Tim. Now, Tim, what happened to being quiet? Now, for the second consecutive integer problem, it's 5 consecutive integers, and this one has the more complicated solve. All right, so we had our let, x plus 1, x plus 2, x plus 3, x plus 4. Okay, now our solve, remember we said to pick out the magic word. Magic word is is. Is going to be the equal sign. So when I write the first part before the is, it's going to be the sum of the fourth and the fifth. So I have the fourth, sorry, x plus 3 plus the fifth, x plus 4 is, that's my equal sign.
Oh my god, I need fortune.
Tim, I need you to be quiet. Now, quadruple the second is going to be 4 times the second, which is your x plus 1. So we have 4 times the x plus 1, and it says 55 more. So we added 55 to the end of the 4 times x plus 1. This one is the first one we've seen in this packet where x's were on both sides. So we distribute the 4, and we get 4x plus 4. That's up here. And then we can combine the 4 and the 55 to get 59. All right, so I have 2x plus 7 equals 4x plus 59. And then when we have x's on both sides of the equal sign, you can't combine them. You need to move the x's to one side. So I moved the 2x. Okay, subtracted that from both sides. So I got 7 equals 2x plus 59. And that gave me my two-step equation. Okay, 7 equals 2x plus 59. We subtracted 59 from both sides. Negative 52 equals 2x. And then we divide by 2 on both sides. And x equals negative 26. Now, we can have negative answers here because it says 5 consecutive integers. Integers can be positive or negative, but just remember by definition, they cannot have fractions or decimals. So, we go back to the let, like when we do with every word problem. Once we solve our x, we plug them in. We have our complete sentence there. The 5 consecutive integers are negative 26, negative 25, negative 24, negative 23, negative 22. And then since the solve was more complicated, the check is going to be more complicated. So I did it in pieces. I did the sum of the fourth and the fifth. That now is, instead of x plus 3 and x plus 4, it's now negative 23 and negative 22. So that adds up to negative 45. 4 times the second is 4 times negative 25 is negative 100. And then I subtracted to show that the sum was of the fourth and the fifth was 55 bigger than quadruple the second. So again, more complicated solve, more complicated check. That makes sense. Now, the last one is consecutive even, so it goes back to the x plus 2, x plus 4, x plus 6, x plus 8, x plus 10. Again, ignore The red on that, that's all the end of the problem. And this one says the product of the third and the sixth. So this is exciting for us because now we have the third and the sixth, x plus 4 times x plus 10. That comes from the lead. We get to FOIL on this one. Whether you FOIL or use double distribute or use the boxes, you should wind up with x squared plus 14x plus 40. Okay? And since it's a quadratic, we are going to set it equal to 0. Okay? And then look to factor. So we subtracted 520 from both sides. Timbo, quiet please. Okay. And then when we did that, we had x squared plus 14x minus 480 equals 0. We then do our factors of sum of. Factors of negative 480, sum of positive 14. Okay, I expect you to have to use the calculator for that because people don't know their 16 times tables or their 30 times tables. We factor it, we tee it up, we get x equals negative 30 and x equals 16. The problem at the beginning said they wanted the negative even integers. So we're going to ignore the positive 16. We're going to keep the negative 30. Go back to your let and plug it in. Okay, and our complete sentence, 6 consecutive even integers are negative 30, negative 28, negative 26, negative 24, negative 22, and negative 20. The check will just be the product of the third and the sixth. So my third is negative 26. My sixth is negative 20. I'll come back over here to do my check. Sorry. Negative 26 times negative 20 does equal 520. And that one checks. So that's all three of the consecutive integer problems on one video. The first one should have been pretty straightforward. The second two, okay, had a little bit more of a difficult solve, okay, but we should be able to solve both linear equations, okay, even if there are x's on both sides, like the top one was. And the bottom one, we had a quadratic, meaning we had to set it equal to 0 and factor. All right. Good luck.